Hello, this is Brian Bebo with Teledyne API. In today's video, we'll discuss the procedures for cleaning the reaction chamber on your 200 series Teledyne NOx analyzer, along with how to determine when you should perform this maintenance. Maintaining a clean reaction chamber will improve the response of your NOx analyzer and will also improve the quality of your readings. As the reaction chamber becomes dirty over time, we must compensate by calibrating the analyzer, both via the offset and slope factors, which are considered software adjustments, and via the PMT gain, which would be considered a hardware adjustment. Over time, as we increase the PMT gain to compensate for a dirty reaction chamber, we also increase the noise of the measurement and increase the analyzer background levels. Properly cleaning the reaction chamber will allow us to reset the analyzer back to optimal factory performance. This analyzer has started experiencing drift issues with its nightly calibration check. So we're seeing basically while we're running, say, a 15-minute nightly span check, that at the end of that 15 minutes we haven't truly lined out or reached our target. The response is still climbing during that period as we switch from our ambient air to our calibration gas. So typically that could be the permeation dryer on our ozone maybe is getting old. This one actually looks okay visually. Most often it's going to be that the reaction chamber has just gotten dirty and it's time to clean it. If you follow really good procedures while you're doing this, you can typically do this in the field. You can get the thing taken apart, cleaned, put back together. If you wear good gloves, if you have the right cleaning materials, within a few hours this thing would typically be stabilized enough that you could run a calibration, get that thing back online. You may have drift over a couple of days, but it's not going to be drift that's going to put you out of your calibration criteria, your acceptance criteria. So really, I'd say 6 months to a year, depending on how dirty your ambient air is, how frequently you're changing your filters, making sure that we're using that 1 to 2 micron sample filter to keep any ambient particulates out of the instrument. Those are going to be key to making sure that the reaction chamber has the longest life possible between these cleanings. So to get started, we've got our instrument pulled out of our rack. We've got it, got the cover pulled off here, and we're going to start by, generally what I like to do here is to get my camera out. I'll get in here, take a few pictures of where everything's at from a few different viewpoints, tubing, electronics, that way I remember how to put this back together. There's also plenty of diagrams in the user manual. But right here we'll see inside our reaction chamber is this section here where the ozone and sample tubes go into our capillaries. It's mounted right onto the photomultiplier tube cooler here. So I'm just going to start off by removing the things that are in the way of getting this out. So we'll take off our sample tube here. You can always tell the sample tube's coming from this mode valve, and then if we follow the other capillary back, it's going to our ozone cleanser and then our ozone generator block. So easy way to remember the order of where these go. So we're going to take off both of these 1/8" tubes. We'll get those out of the way. This electrical connector here, we can just squeeze and pull that off. Go ahead and get this 1/4" tube out of the way. Make things easier to work here. That's our exhaust out of the reaction chamber and into our ozone destructor. It's a heated destructor there. So we're going to get a couple wrenches in here. This is all SAE. Most of the tubing in here, if you've got a 7/16, a 1/2" and a 9/16 wrench, you'll be all set for any of the pneumatics that you need to take off around here. Got that out. We've got this out. That's a little bit in the way, but we'll be able to work around it. So we've got 4 Phillips head screws holding this guy in. 2 of them are going all the way through, and 2 of them are going part of the way through. I'll grab my Phillips driver, and we'll get those screws taken out of there. So those are the 2 that pass all the way through to our PMT cooler. You'll see they're coming out there. Those will be our longest ones. So those are on the flat surface of the reaction chamber block here versus the other 2, which are a little recessed. Try to get that out of there. You'll see a lot of heatsink paste on there. So once we've got that out, typically what we're going to want to do is cover up with something dark just to keep our ambient light out of the photomultiplier tube. If we can keep the light out of that tube, our response is going to be a lot better once we get this all put back together. We won't have to wait for that PMT to settle down as much. Just keeping track of O-rings and parts in here. I'm going to go ahead and set this down, and we'll pull apart the other two here that are holding the actual chamber itself together. So these will be our two shorter screws. Set those aside, and we can slide this piece out. There's a paper filter in, or paper seal in there. We'll keep that in. We've got our infrared window here, which has been together for a little while. Not sure if we can see that on the camera or not, but it's definitely dirty in there. Now this one has the nozzle modification that directs our flow out as it comes into the chamber. So rather than coming straight in at the infrared window, it directs it out, which gets the buildup along the sides of this chamber wall. That improves the life in the time between cleanings, but it doesn't eliminate it. If you're able to see in there, actually let me try it over here. If you can see inside there, you'll see there's a little bit of debris. It's dirty. That's our goal today, is to clean that out and to clean any surfaces here that we see. Okay, so I'm going to grab another Kim wipe here and some of this 91% isopropyl. Get this little dab on there. You can clean this infrared window, get all that debris out there. You may need to do this a couple times to get it very clean. We don't want to see any residue left on there. Grab another one of these. Kim wipes work really well. They don't leave any dust behind. The thing that's really important are these gloves. If you've got oils from your skin getting onto this and then you put it back together, you're going to find out that it's going to take a long time to stabilize. The cleaner you can keep it, the cleaner you can get it, the less time it's going to take before you're kind of back to normal and not making those frequent span adjustments or PMT adjustments to your instrument. So, pretty clean smudge there. A little dust on it, but that'll be alright. Get that off there. Have some canned air to get that last little bit of dust off. So we've got that clean. Grab another little bit of alcohol. We want to clean out this chamber. And see how much black stuff's coming out of there. Some of that's coming off the O-ring, but this one was very dirty. And you can change these O-rings. Typically they'll last a few cleanings. It's not bad to have some on hand. If you get this apart and find a bad one, then I'd want to have all these O-rings to put back together. I don't happen to have them right now, so I'm going to put it together without doing that. Okay, I've grabbed a 16th inch Allen wrench here, and what I'm going to do is remove this gold colored nozzle director. Should be pretty loose. We want to clean this thing out as well. Use a Q-tip with some isopropyl on it. We'll be able to get down inside there, get all that crud out. If I had an ultrasonic bath, I would put some of these parts into that with some just deionized water. When I use deionized water, I'll still typically wipe everything down with methanol afterwards. I feel like it really gets any of that moisture off and cleans it up. But the whole outside of this has got just a little bit of buildup on it too, so it's going to help a lot get the nozzle clean. And then we want to clean off any of these parts in here that we've got exposed. Just get it all as clean as we can. See the concentric tubes here where the ozone and the sample come in and introduce to the chamber here. Those are a little tricky to clean out without an ultrasonic bath, so we're not going to be able to get in there right now. Should be fine. Really what we're looking for is the surface area of the reaction chamber. That's where the dirt is going to make the most difference, getting it clean. That's where the actual chemiluminescence occurs. So the other thing I'm going to do while I have this apart is replace the fritted filters on our sample orifices and clean out those areas. So use a 9/16 wrench. These would be a little easier to get off while you've got the whole thing still assembled, but it's manageable here. We want to keep track of these two as they are different sizes. So we've got our called the back one, or the one closest to the chamber, and that's how I'm going to lay these out so that I can keep them in the right positions. These are overly tight, really. They don't need to be that tight. There we go. Just make sure you use wrenches that are the right size and that are backed up. So we'll keep these We've got another video on our YouTube site that shows the way that these come apart and go back together. But for this video, I'm going to do it again. That other video is really nice. It's got some sort of jiffy action going on there. But if we put 2 wrenches on here, we can split this apart. Not lose any pieces. So we're going to see the top piece. There's going to be a spring, and then you see a lot of crud coming out of there. Sometimes these pieces are a little hard to get out, and you've got to be careful about poking down in here because you don't want to break that ruby orifice. Let's see if I can give it a good tap. Now we're going to have to push it out. I may be able to use this Q-tip without any cotton on it. Nope, that won't work either. I'm going to carefully try the Allen wrench here. It doesn't take much. There we go. So what you're going to get out of here is a little stack of pieces. There's going to be our fritted filter here, an O-ring, and then our capillary. I'm going to put the link to these. These are consumable parts. I would recommend just throwing these away. I'll set that one right to the side. I'm going to grab a fresh Q-tip. Try to get down in here and clean these parts out as much as possible. That's very dirty in there. So a blackish, powdery substance. Okay, so back to it, cleaning out all these parts. Get a little more on the outside of. Really, we just want to clean every surface. If we do that, we'll be in good shape. Part of our consumable kit will come with springs and these filters. So if you've got our consumable kit, you'll be all set. Clean this guy off. Okay, so grab a couple of new Fritz. And put it back together in the same order. We'll have our capillary. Just want to get that in there nice and straight. Okay, it's all the way down there. Get our O-ring in and our new fritted filter. Make sure they're all down all the way and seated. If you got good lighting, you'll see they're down there. We're going to put our spring back in, and when we put this piece on, we want to note that one side is a swage lock compression fitting, the other side is a straight thread with an O-ring seal there. So we need to make sure we get that in the right orientation. You can tighten it back up. Remember, not as tight as I found it. Just snug. It's an O-ring seal, so just snug is perfect. So this was our outer one. Alright, so you can see we've got our chamber back on there with this words facing up, so we know what part numbers we need in the future. We've put our two shorter screws back in, got them both started so that they're in the recessed corners of the block here, and we're gonna go ahead and snug these up. So remember, this is an O-ring fit or O-ring seal, so we want to not tighten these really any more than hand snug. It's not necessary to tighten them very much. While we're looking at it, you'll see this is our safety heater. So it's just a snap action thermostat. Over here. So anyway, this is just a snap action safety thermostat here. We heat it with this little rod heater here that's pressed through. It's got a heat sink paste on it. And then we measure with this temperature sensor here, and this is just going to cut power if for some reason the system runs away and tries to apply full power with no control to that rod heater. That'll be our safety. Actually, sorry, there's a heater here and a heater here, and the temperature sensor has the yellow leads coming out there. So we've got our reaction chamber back on here. I'm going to slide this glove out and feed this back into the TNT cooler. Okay, we're putting our reaction chamber back on here with our two longer screws. Feel them make contact if you sort of rotate that a little bit. So get them both down before we tighten them all the way, just to make sure that we've got a nice flat fit there, and that will tell us that our O-rings are all sealed up everywhere. So remember, just hand tight, no excessive force needed. So now we'll go ahead and put our capillary blocks and filter blocks back in here. That's a 9/16 wrench. Don't over tighten, just until it stops. We'll put our sample filter and capillary back in. There we go. And these will go right back on top. These are our swage lock compression fittings, so same thing. A lot of times these get over tightened and bite through the Teflon tubing there, so we don't want to do that. Just get them just tight enough. That's what I said, just tight enough. We'll plug our harness back in here, and our exhaust tubing here. These union fittings, just remember, always use 2 wrenches so you're backing up this fitting. Don't just try to turn on this and put all the force through there. So we're going to use that 1/2" wrench on the union. And that one, same thing down here. One of these is a pipe thread into the reaction chamber, but we don't need to stress that and tighten it anymore. It's plenty tight, so make sure and back those fittings up. Close our alcohol so it doesn't evaporate away, and that's it. That's our reaction chamber cleaning for a T200 chemiluminescence analyzer of any version. Again, you may or may not see the gold nozzle director in there. That's a feature we put on all of them now, so if you've got an older analyzer, get in touch with us. I'll put that part number in the video so that you've got that. That's it. Alright, we've completed the reaction chamber cleaning on our 200 series NOx analyzer. Hopefully, you can see that this is a relatively easy process that can greatly improve the quality of your NOx data. This post-maintenance GPT-0 and GPT shows an improvement in response compared to the one shared at the beginning of the video. Following maintenance, our analyzer reaches calibration targets much quicker, and it lines out much faster and in a more repeatable manner. This data was collected approximately 12 hours after the instrument was turned back on, but the calibration was performed within a few hours of turning the instrument back on. Please don't hesitate to contact our expert technical support group if you have any questions or concerns related to this procedure, and make sure to read up on the procedure in our user's manual. And remember, use gloves and keep things clean.